that gives the gradient of the graph y equals f of x at the point x is written as f prime of x, where f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x, all of that over h. Essentially, what this means is, let's say you have some function, right? You have some function. This is f of x, right? And what I'm saying is that if I want the gradient, so the slope of this function, right, in a functional form, so the derivative, like that gradient will be given by this thing we call the derivative, which we use this notation f prime of x, and this derivative at its actual most like simple form, at its basic like 1 and zeros like fundamental form, it's equal to this monstrosity here. And this monstrosity, right, super simply, all this means is this, okay? A slope, a gradient, right, is just some delta y over delta x, right? Do you agree with this?
Yes.
Okay, so this is the slope of some function. So this is what we call also the gradient. It's like how quickly it increases or decreases. All right, so if you look at this, well, y, the value that is given by y is actually given by your f, right?
Right.
Okay, and what we're going to say is, let's say we're going to look at the graph for a second. We're going to say, okay, I want to find the slope at this point here, let's say this point here, okay? And I'm going to approximate that by taking 2 points. So if you want, you can zoom in a little bit more to the graph. And I'm going to approximate this slope by assuming it's a linear, okay? And saying that I'm going to pick a point here and a point here. I'm going to take the line between them, right? And I'm going to say that whatever slope, let me use a thinner version of this draw tool. And I'm saying is I can approximate the gradient of this function at this point if I take 2 points, right? So let's have this point that we're interested in be in between these 2 points. And I'm going to say it's going to lie on the line created by those 2 points. And then I'm going to say, well, since all 3 points are on the line, then when I find the slope given by these 2 points that I've found, right, then that will be the slope of the function I'm interested in at that point. And so the idea is that if you take 2 points, right, which are a distance as small as possible away from your point of interest, then you can approximate it better, right? And so if you do this, like if you take infinitesimally small distances, eventually you're going to converge to the actual gradient, the slope of this function that we're interested in. So all this really means, when you look at this monstrosity of an equation, it's, let's zoom out a bit and go back to here, all right? This here, all it's saying, okay, is take some point at h distance away from the point that we're interested in, okay? And one who's, I mean, I guess it doesn't really matter where this point is. It could be the point we're actually interested in. It doesn't really matter.
Wait, so the point is xh, right?
X plus h.
Yeah. But like, what would the point be like here? What is x and what is h, for example?
So h, okay, if we go back to the graph, right? We're
H is the distance, right?
H is the distance in x, right? Between where we want to be and what point we're actually using. So it's going to, what we're going to do here is going to look slightly different from the equation, but it all is going to work out the same way, because like if you take the limit as h becomes really tiny, it doesn't matter which point you take because you're going to converge to the same thing, right? So let's say I chose 2 points, this one and this one, but you could just have easily said, well, okay, I'm going to take, instead of 2 additional points, I'm just going to add 1. So let's say I delete this. Let's say I delete this here. Let's say I'm going to take some point here. I'm going to say I'm looking for this slope. So this h, if this h goes, like if the limit of this h approaches 0, then this slope is going to be a better and better representation of that. Like
So the smaller it gets, the better.
Yeah. So just to relate this to the slope equation that you're familiar with, delta y is equal to y2 minus y1,
Yeah.
right? And then your delta x is equal to x2
minus
minus
x1.
x1. Sure. And then really, like the f prime is going to equal this, okay, but in its most like infinitesimal version. And so really what that's going to be is I'm going to say, okay, I'm going to take some point that is, I'm going to create some line, okay? So I'm going to take this is my y2. This is this here, right? Does that make sense?
Okay.
So this is my y2. And I'm going to take minus my y1, which is just f of x, okay? And then my delta x is just going to be x2 minus x1 is h, because that's the difference between them. And then what we say is if we take this limit, we take the limit as this h, this distance h approaches 0, then we're going to get the slope exactly. So that's all this big monstrosity means.